live. All right, so rational numbers and irrational numbers. There's different types of numbers that are all considered to be rational, and then there's different types of numbers that are irrational. That's essentially what we're defining right now. So does anybody see a word in the word rational?
Ratio.
Good, ratio. Does anybody remember how we can write ratios? So for example, if I was talking about a 1-to-3 ratio, I could use words.
1/3.
Good, I could write it as a fraction. Very nice. So a rational number is any number that can be written as a fraction. A rational number is any number that can be written as a fraction. You should be writing this down. So obviously, if any number that can be written as a fraction is rational, then fractions are a type of rational number, right? That makes sense. Fractions can be written as fractions, 1/3, 1/4, 2/5, etc. Those are some examples. Those are all fractions, therefore they're all rational numbers. Integers, which are positive or negative whole numbers, can be written as fractions. Any whole number can be written as a fraction. If I have -2, how would I write that as a fraction? Mateo?
When you write 1 over -2, or no, 2 over -1.
There you go. You can just put it over 1, right? So the negative can be in the numerator or in the denominator. So 2 over -1, -2 over 1. Either way, you can write it as a fraction. Any whole number, like 3, can be written as a fraction by putting it over 1. Then you have your, what do you call these? Repeating decimals. So for example, a repeating decimal could be 0.3 repeating, 0.6 repeating. Does anybody know what 0.3 repeating is as a fraction? Good, 1/3. What about 0.6? If 0.3 repeating is 1/3, double 0.3 repeating, Brianna? Careful. Good, 2/3. So repeating decimals can be written as fractions. Terminating decimals, sorry, I had to think about it. Terminating decimals. So in other words, decimals that end, 0.25, 0.5, 0.2. These are all examples of terminating decimals. Does anybody know what 0.15 is as a fraction? 1/4, good. What about 0.5 as a fraction? Hopefully we all know that one. 1/2. And 0.2 as a fraction? Mateo?
2 over 10.
Which simplifies to?
1 over 10.
Perfect. And then finally, our last type of rational number are the square roots of perfect squares. I'm going to write it this way. Square root of perfect squares, or the cubed root of perfect cubes. So for example, the square root of the square root of 16 is positive or -4. Whoops, I don't need that square root. Gives me a whole number. The cubed root of 8 is +2, right? I'm getting whole numbers back when I take the square root or the cubed root of perfect squares. Okay, did I lose anybody with all of these numbers that we've kind of used to working with, right? Like we have done some work with fractions. We've definitely worked with integers. Whenever we have certain decimals, you guys ask, or certain fractions, you guys will ask me, can we write them as decimals? And usually I'm like, no, leave your answer as a fraction. And we've been working with perfect squares and perfect cubes now. And the reason why is because non-perfect squares, and since I'm talking about it, we might as well add it in. So the square root of non-perfect squares And the cubed root of non-perfect cubes are what we call irrational numbers. And I'll show you why in a minute. Okay, so irrational. Think about when your parents are acting irrationally. You probably did something for them to be irrational, or maybe they're having a hard day or whatnot. It's not necessarily always you, but let's be real, sometimes it is. So when they're being irrational, right, you can kind of picture it. They're red, they got like crazy eyes. You can almost imagine the smoke coming out of their ears, right? Does the yelling ever end? No. Are they making any sense? Not really, no. Hence why they're being irrational. Can you predict their next move? You're saying you can? Oh, you think a grounding is coming. But do you know like the next thing that's going to come out of their mouth?
No.
Not necessarily, right? So when our parents are irrational, they're unpredictable, they never end. The same is true with irrational numbers. By definition, they're numbers that cannot be written as fractions. But really what that means is they're non-terminating. Here's where the yelling never ends. Non-terminating. The decimals doesn't end, and non-repeating, meaning there's no pattern to how they repeat. There's no prediction. You can't make a prediction about what the next digit in that decimal will be. So irrational numbers are typically decimals that are non-terminating, non-repeating. So for example, some of you have graphic calculators. If I were to look at the square root, somebody give me a non-perfect square.
60.
Okay, so the square root of 60, right? My calculator is storing the first couple digits, but technically this non-perfect square, these decimal points are going on forever. 4, 5, 9, 6, 6, 6, 9, 2. Right? Notice how the actual numbers, like the digits of 6 are repeating, but there's no pattern to how this repeats. I don't know what the next number is. It's non-ending, just like the yelling that never ends, and non-repeating means you can't really predict what the next digit will be. What about a non-perfect cube? Somebody would like to give me a non-perfect cube? Okay.
Like 5.
Perfect. 5 is a non-perfect cube. Okay, so to do that in the calculator, you go to math. You're going to go down to 4, type in 5, hit enter. So we get that the cubed root of 5 is about 1.709975947. Again, just showing you that it never ends, just like the yelling, and you can't predict the next number. That's what I mean by non-repeating. So non-perfect squares, non-perfect cubes are examples of irrational numbers. Does anybody know of another number that never ends and has no repetition to how it repeats? It's kind of like a special math number that we use in geometry. Yeah, pi. Pi is approximately 3.1415. Those are all the digits I memorized. 3.14159264. Again, the calculator is cutting it off, but technically these digits never stop, right? The repetition never ends. Sorry, the decimal never ends, but there's no repetition to how the pattern's created. So pi is another type of irrational number. So long story short, from the top section of our notes, what we're going to be doing is classifying numbers as rational. You can write it as a fraction, so it's rational. If you can't write it as a fraction, it's irrational. Or if it's the square root or cubed root of a non-perfect square, it's considered to be irrational. Does that make sense? Okay, so now looking at the next section, I have this decimal. It doesn't end, hence why I have the ... but is there a pattern to how it repeats?
2, 5.
Yeah, I can rewrite this as 0.25 repeating. So since it's a repeating decimal with a specific pattern, is it going to be considered rational or irrational?
Rational.
Good, this is a rational number. Most numbers that we deal with are rational. What about the square root of 36? What would that simplify to? Good. Can you write 6 as a fraction? So is it rational or irrational? Good. What about the square root of 7? Or sorry, the opposite or the negative value of the square root of 7. Can you look at the square root of 7 and like evaluate it right away? No, right? Is 7 a perfect square? No. So since we're taking the square root of a non-perfect square, is it going to be rational or irrational? Irrational. Good. Very nice. So this one was rational, rational, irrational. Go ahead and try A, B, and C on your own. I'm going to pause the video and freeze the screen. All right, so you should have gotten that the first one is irrational. 10 is not a perfect square. You okay? You're good. Negative 2 2/5 is already written as a fraction, so therefore it's rational. The square root of 100 is 10, which we can write over 1, which can be written as a fraction, therefore rational. Okay, so on the back, now what we're doing is using the chart, we want to compare if the square root of 5 and 2 9/10 is greater than, less than, or equal to. So when you're taking the square root of a non-perfect square, or in other words, when you're looking at your irrational numbers, you need to estimate them to the nearest whole number. So what two perfect squares does root 5, you're looking down the square list, does root 5 fall between? 2 is the square root of 4, and 3 is the square root of 9. Yes. Is it going to be closer to 2 or closer to 3?
2.
Good. It's going to be closer to 2. 2 9/10, is that closer to 2 or closer to 3?
3.
Yeah, that's going to be between 2 and 3, closer to 3. So which one's bigger? 2 9/10. So you should be using the greater than symbol. Closer to 3 is bigger than closer to 2. Okay, looking at root 10, what two perfect squares does root 10 fall between? Anya?
9 and 16.
9 and 16, which is really 3 and 4. Okay, is it closer to root 9 or closer to root 16? Yeah, closer to root 9. So therefore, this is going to be closer to 3. So looking at this, what symbol should we use? 4 is blank compared to 3. Yeah, greater than. Oh, I said this was less than. I meant greater than. I meant that root 5 is less than 2 9/10. It should be eating the bigger number. Okay, looking at this one, the cubed root of 220 is going to be between the cubed root of what numbers? Anya?
216 and 343.
Good, 216 and 343. The cubed root of 216 is 6, and the cubed root of 343 is 7. Which one is it closer to? Yeah, it's closer to 216, which means it's closer to 6. 6.75 is falling between 6 and 7. Is it going to be closer to 6 or closer to 7? Yeah, it's going to be closer to 7. It's practically on top of 7. So now if we're comparing 7 with 6, what would that be? 7 is greater than 6. Very nice. Okay, we still have about 8 minutes. Let's go ahead and look at the practice. So for the first part of this, 1 through 8, you're using the notes back here as to whether it's rational or irrational. If you can write it as a fraction, it's rational. If you can't write it as a fraction, it's irrational. And then down here, you're estimating to decide whether it's greater than or less than. You guys can go ahead and start. I'll pause the video.